Everyone, welcome to our week 7 live classroom. I know I say this every week that it's like crazy that we're this far in the semester, but we've never been this far in the semester, so this is like crazy. So everyone, welcome to week 7. I have this announcement here that has our spiritual discussion post in it for extra credit. It's been going on all semester. If you forgot about that, it's still there, and you can still get extra credit every week for posting on that discussion just in this announcement. And then also I posted another announcement today. After reading a lot of your journal entries, a lot of you were really concerned about finding errors and spending hours upon hours upon hours looking for errors in your code. And I think this ended up being like a 10-minute video or something like that. But I took my assignment 1 from last week, the same one that you guys did, with like the shoes and galoshes and things like that, and I added like a billion errors in it. And then I just go through fixing them one at a time, showing you guys how I do it. So yeah, if you haven't watched that, and if you're struggling with finding errors, go ahead and review that. So another just reminder, we have this video spreadsheet. A lot of people getting into this arithmetic, they're like, hey, I don't know like where to get help on this kind of stuff. This is an incredibly valuable resource to you. I have an assignment introduction video for every single assignment that you can watch at the beginning of the week. And then once that week is done, you can watch my walkthrough video of me completing that assignment. You know, so if you had questions about assignment 6, you could watch this video and see the finished product of it and see where you went wrong, or if you wanted to just see how I did it. Meanwhile, if you're like halfway through a program and you're stuck on something and you can't figure out how to get it finished up, these programming exercises, these videos I do from start to finish, and they're from the end of the chapters in your book. So they're really similar to your assignments each week. And so if you end up getting stuck, you can watch these videos as well. So, and then the last reminder that I wanted to share with you guys, this is from our syllabus, but there is a link inside of our syllabus to schedule a time to meet with me. And if you click on a day, you can see what times I'm available if you wanted to meet with me on a certain day, okay? And if you need a time outside of that, just shoot me an email. I'm happy to set up another time to meet with you. But this is a really easy time, or a really easy way to set up an appointment with me, because we don't have to send emails back and forth. You can just schedule a time and it'll get added to my calendar. So, and that is in the syllabus. Let me just find that for you. My live classroom, dispute auto grader. I thought it was in my, right here. Click here to set up a 15-minute appointment with me. So here in your syllabus. All right, any questions on any of this stuff? Okay, Shonda, I didn't see you come in. I'm glad you made it. All right. So any questions on week 6 before we dive into week 7? Sweet. Well then, without any further ado, let's look at week 7. This week, we are dealing with logic. All right. There are several logical operators that JavaScript uses. These are really common across pretty much every programming language that I've seen. I guess some of them are a little bit unique, but they're all really similar. But every one of them will have a not operator. So if anytime, let's say I wanted to find, or let's take your shoe program from last week. I could say if the weather is not equal to rainy, then I could do like shoes or something like that, you know. So that will just reverse whatever it is, and it is just the not operator. The and is a binary operator that combines 2 conditions. I'll show you guys examples of this. But the template for the and, or, and the exclusive or is like this. So I could have a condition. So I could say if x is less than y, and this double ampersand, and y is greater than 20, or something like this. I have my inclusive or, which again, I could just stick right here in place of operator. I could say if x is less than y, or y is less than 20, okay? And in this case, if either one of those was true, then this if statement would equate to true and would execute the code inside of it. Then I have my exclusive or. This one isn't as common as the first 3, but it is there, it does exist, and it's important to know what it does. Let's take my if X is less than Y or Y is less than 20 example, if I put an exclusive OR in there, then only one of them could be true for the if statement to equate to true. If both of them were true, it wouldn't be true. Okay, the exclusive OR says it has to be one or the other. Okay, whereas the inclusive OR, it could be either or both. Any questions on these before we look at some examples? Okay, so let's imagine this table, okay? A program that reads a girl's age from the keyboard and determines which class she should attend, okay? I'm actually gonna have to change this since the 11-year-old thing came out. Anyways, so you have your age.
Well, and there aren't any classes anymore.
Yeah, that right? Seriously. Yeah, I'm gonna have to change this. Michael asked, do you have a good example of an exclusive OR? I have never seen that used. Yes, we will look at some in a little bit. With the exclusive OR, it's important to recognize that if you never want to use it, you never have to. There are ways to get the same result set using an inclusive OR, sometimes mixed with the negation operator. So really it isn't as common because you can get around it. You can do the same thing using other things, but I'll show you a couple of examples. All right, so assuming that we still had, young women's classes, and that these were the conditions, I could imagine that if a girl is younger than 12, she'll be in primary. That's still true for the most part. If she's 12 or 13, she'll be a beehive. 14 or 15, a mime maid. 16 or 17, a laurel. 18 or older, she'll be in relief society. Okay. Oh, whoops. Let me pull up my code here. Week 6. Oh, we're in week 7. Week 7, girls' classes. All right, so check this out. I have a function called choose class. All right, the only thing that'll show up in the body of my page is just please enter your age, have an input, and then a button, and then an output. Okay. And then in here, we will get the value from the user. I'll parse it, so we'll have a whole number for our age, and then have var class. All right. If age is less than or equal to 11, we'll assign class at primary or to primary, okay? Else if, notice my and operator here, if age is greater than 11 and age is less than 14, okay? I could say this exact same thing using the or operator in this case because I'm dealing with whole numbers. And I could say if age is equal to 12 or if age is equal to 13, okay? I could also put in an exclusive or here because it's never going to be 12 and 13. I'm dealing with the same variable here. And so I could put an exclusive or here and that would work just as well. Okay. So there are a lot of different ways to do this exact same thing in this case. All right. But if the age is 12 or 13, she'll be a beehive. If it's 14 or 15, she'll be a mime maid. Now I put in an error right here because if I say or 15, this will always equate to true because 15 will be considered a value that is present, and so it will be considered true as opposed to false. If I wanted to say if age is equal to 15, then I have to say age equals 15, okay? If I just put 15, then this would always equate to true. Okay? Then if age is equal to 16 or age is equal to 17, and so forth. You can see we're kind of building on what we did last week with our logic, our if statements and everything, but we're adding a little bit of complexity with multiple conditions inside of our if statements. Okay. Any questions on this? Okay. One other way to do this, I could actually write this entire thing without using these operators. I could say if age is less than 14, because at this point, if age is less than or equal to 11, it'll go into this if statement, okay? So if it gets to this point, if the code reaches this else if statement, I know that age is greater than 11. So right here, I could just say, okay, if age is less than 14, and that'll already encapsulate ages 12 and 13. And then same thing with here, I can just say if age is less than 16, or if age is less than 18. Because if it reaches this piece of code, I know that it wasn't less than 12, it wasn't less than 14, it wasn't less than 16, and that's why I'm here, and so I can assign Laurel Otherwise, if it reaches this, I know that all of these were false, and I can just assign release this ID. Okay. So a lot of different ways to do this. I threw out these examples just because I wanted you to see the ands and the ors being used. Okay. Questions on this piece of code?
Is any one particular one more generally accepted, if that makes sense?
Yeah, it does. In this case, I would say do this. Okay. If at any point you can avoid using multiple expressions inside of an if statement, you should avoid it. Okay. Because this is a lot easier to read. There's just less going on. But there will be many cases where you have to have multiple conditions inside your if statement. And then as far as how you want to organize it, if you wanted to say is equal to 14 or 15 or is greater than 12 and less than 16, you know, whatever, it's totally up to you. Whatever makes the most sense. So, all right, next example. According to the Disneyland website, guests wishing to drive a car on the Autopia must meet one of the following height requirements. Either they have to be 54 inches or taller to drive alone, or they have to be 32 inches or taller and be accompanied by someone who's 54 inches or taller. Okay, so let's look at a program for that one. So either the driver is 54 inches or taller. Okay, if you're 54 inches or taller, check. We'll go ahead and skip all of this right here, and we'll just say message equals enjoy the ride, and we'll output that message to the div. Okay. But if this is false, then I'll say or, and then my program will check this. And here it says driver is at least 32 inches tall, and the passenger is at least 54 inches tall. Okay. Notice my parentheses here. That's really important because if those parentheses weren't here, my program wouldn't quite function as intended. Okay. If they weren't here, then we have to think about the order of operations. Okay. So the or and the and have the same order of precedence, kind of like addition and subtraction. If I had like var x equals 5 plus 6 minus 2, okay, I'm just going to read left to right because addition and subtraction have the same level of precedence. With this, the or and the and have the same level of precedence. So I would say if driver is 54 inches or 32 inches or greater, and passenger is 54 inches. So in this case, regardless of the height of the driver, the passenger would have to be 54 inches or taller because I took out those parentheses. Okay, but in this case, it's saying, you know, if the driver is 54 inches or taller, or the driver is 32 inches and the passenger is 54 inches. Okay. Questions on this program? Oh, Michael said, so if they were both and, you wouldn't need to use the parentheses. Yes, that is correct. So if I had a certain use case, you know, if I had 3 conditions that I was checking for, you know, let's say I had var x equals true, just a Boolean value, and var y equals false, and var z equals true. And then in here I said x and y and z, okay? That will just check to see, that'll just check the value of each of them. It doesn't matter what order they're in or anything like that, you know, and as long as all of them are true, all of them are true, then we'll go into our if statement. With this, you know, if I had another one like it's a Saturday or the park is open, you know, then I could do something like that as well. So great question. All right, let's actually run this real quick. I'm going to copy this file path, go over to my browser and paste it. And we're going to do a little debugging practice. So I'm going to put a breakpoint on the first line inside of my function. So I have my function header. I'll blow this up a little bit. I have my function header, and I'll put a breakpoint right inside of there. So as soon as this function gets called, I'll stop my code. So let's say the driver's height is 40 inches, and so is the passenger's. Okay. I can see driver's height is the number 40 because I parsed this. Passenger's height is also 40. And then in here, I can see, is driver greater than or equal to 54? That's false. Driver is greater than or equal to 32? That's true. and passenger is greater than or equal to 54, that's false. So notice I could highlight each one of these chunks and see what it would get independently. I can also highlight multiple chunks and see what that whole thing will get. Okay, so that's false, which means this will also be false, which means this entire if statement is going to be false, and we're going to come down into here. Okay, but that had our old code. It should be like this. Driver's 54 inches, or they have a 54-inch passenger with them, and they're 32 inches tall. So I'm going to refresh this. You can see that got updated. Say I put 40 in here and 60 in here. All right, driver's 40, passenger 60. Okay, I can see this part right here equates to false, but we have this inclusive or. So as long as this equates to true, then our if statement will equate to true. And I can highlight this and see that it does equate to true. And so if I hit F10, you'll see the message comes up as enjoy the ride. Okay, so debugging is huge for different things like this. The more complex your if statements get, whether you have multiple conditions inside of the parentheses, or you have nested if statements or things like that, the more helpful the debugger is, because you can break it up, be like, oh, what's this? What's this? What's this whole thing? You know, and see what each chunk will be, and that can help you while you're figuring out your programs. All right, exclusive or. Okay, here's a small programming example from a program that includes buttons in its user interface. This code is used to enable or disable a button. Okay, this is a good example of when you might want to use an exclusive or. Okay, notice that this chunk of code right here and this chunk of code right here, they do the exact same thing. Okay, but one of them is a lot more verbose. Okay, so right here I'm saying if is enabled is false, and we send the command to enable it, then we'll enable the button. Otherwise, if is enabled is true and we send the command to disable the button, then we'll disable the button. Okay, but we know that anytime, you know, if I just like think about like a light switch, anytime it's on, if I touch that light switch, it's going to be to turn it off. Anytime it's off, if I flip that light switch, it's going to be to turn it on. Okay, it's not like it's going to be on and I'm going to flip the light switch to turn it on. Okay, because of that, I can say if is enabled is true, or exclusive or the command is enable, then we'll just toggle the button. So if is enabled is true, then all we'll need to do is just say, okay, then we'll just have to turn off the button. Or if the command is enable, then we'll know that we'll just need to enable the button. Okay, so with either one of these, we'll know that it'll take that opposite side for either enable or disable the button, and it'll just toggle it for us using this exclusive or. Does that make sense? So exclusive or is kind of like a not or. Yes, a little bit. Okay, I mean, not quite, but yes, in a way, definitely, Michael, because it's saying either or. Okay, either or is the best way to think about it, because it can't be both. Okay, it has to be one or the other, and so not or. I can see why you would think of that. So yes, in a way, good question. Any other questions about this one? Okay. Another way to toggle the button, if is enabled equals true, and this is not equal to the command being enable. Okay, so notice I did it in a single line of code right here, but I didn't use the exclusive or. I didn't even use or. Each one of these will equate to a true or false value. Okay, so if is enabled equals true, or the command is equal to enable. Okay, and that'll each of those will either equal true or false. And then if those are not equal to each other, then we'll toggle the button. Okay, so notice that there were 3 ways to do a very simple thing in this example of toggling a button. David, welcome, glad you could make it. And you will continue to see increasing levels of variance in your programs as the semester continues. Okay, there are a lot of different ways to do a single task. All right, logical equivalences. I made a note here to not memorize this. This is a screenshot I took straight out of your book. But I don't know if you guys remember like being in school back in elementary school or middle school or whenever they taught it to us, but all these like commutative laws, associative, distributive, all these different laws, okay? And they hold true in programming, all right? Now, I say not to memorize them. It's important to understand that they exist and that if I have a piece of code, let me pull up my text editor here. If I have drivers greater than or equal to 54 and this condition, this would be the exact same thing as saying, wait for it, that. Okay, I changed the order, but with this inclusive or, the order really doesn't matter. And so it will equate to the exact same thing. All right. And that is an example of a commutative law where A or B is equivalent to B or A. Okay, same as A and B is equivalent to B and A. Okay, all of these laws hold true. All right, and the more complex or the deeper you get into programming, the more complex you will see these things being true. The most questions that I get are about De Morgan's law. Okay, De Morgan's law has to do with the negation operator. Okay, so if I have not A and not B, that's the same thing as saying not A or B. Okay, so if I go back into my text editor here, I'm not going to use this example. We're going to do something a little bit more simple. So if I had var A equals true and var B equals false, I could say if not A or not B, this would be equivalent to me saying not A or B. Okay, so notice I put that negation operator right in front of my parentheses, which will negate the output of this. Okay, and so these are equivalent statements using De Morgan's law. All right, I can kind of change the order of things. And the reason why I say not to memorize these is because I don't have to know multiple ways to write the same thing. Okay, if something makes sense to you, use it. Okay, if it works, then that's fantastic. You don't have to be like, oh, I could like completely reverse this like 10 different ways and get the same output. It's possible, you can, but you don't have to. Okay, so when you come across this and you're reading or you're thinking about it, just remember you don't have to memorize these. As long as something makes sense to you logically and it works in your code, then that's all that matters. Okay, but it is important to know that there are a lot of different ways to write things, and that's okay. Okay. Any questions on these logical equivalences? Okay. Sarah, I thought De Morgan's law had and, the double and. It can, it doesn't have to. We will look at some examples that use ands, and oftentimes when you convert it to a different form, you'll switch from and to or and different things like that. If I go back to my code, if I had like if A and B, then I could also say if not, and I could like negate these and have like a double negator in there, and that would also be the same thing. But there's lots of different ways. You'll see many examples, both in your text and in real life, where you will have like an or operator or an and operator, and that can be basically reversed using De Morgan's law and using negation operators. Okay, and I think I have a couple of examples that I'll show you guys here in a little bit. Okay, so using De Morgan's law. Here we have this example. Imagine that the dean of your college has asked you to write a program to print a list of students who are not on the dean's list for academic excellence. Okay, so to get on the dean's list, you have to have at least 32 credits with a GPA of greater than 3.5. All right, so I could use De Morgan's law to get the opposite of that. And notice all I'm doing right here is just negating this, and that will give me everybody who's not on the dean's list. Okay, I could also use this. I could use the principles of De Morgan's law to basically reverse this. So let me come into here. I say if GPA is greater than 3.5 and credits is greater than or equal to 32. Okay, and I'd have this line of code. I could write that same thing by saying if, and let's think through this a little bit. So I'm going to get everything of 3.5 or greater. So that I could say if GPA is less than or equal to 3.5, or credits is less than 32, and negate this entire thing. Okay, so I start off thinking, okay, I need this opposite and this opposite, and if I negate that whole thing, then it'll give me the same result set. Let me blow that up a little bit so you guys can see it. Okay, so each one of these will give me the same result set. I used De Morgan's law and switching the and to an or to negate it. So Sarah, I think that's what you were thinking, you know, being able to convert something into a different form if I didn't want to use an and, if I wanted to use an or, and then negating that. Okay. So it looks a little bit confusing. Okay, there are a lot of like crazy symbols that we've been looking at for like a week. All right. The more you practice with it, the better you get. And again, like I said earlier, you don't have to memorize every possible way that you could write this out. There's probably like 50 that I could get the same result set. Okay. You should write out whatever makes sense to you. Okay. And perhaps what is the most simple for you. Okay. All right. And then from Wikipedia, I just pasted this. It's a pair of transformation rules that are both valid rules of inference. The rules allow the expression of conjunctions and disjunctions purely in terms of each other via negation. Okay. All right. Advanced word search. Okay. Now this is kind of cool. I don't know if you guys have seen Google's advanced word search, but it's pretty fantastic. I'll pull it up here. Search. So in here, I actually use this all the time. I love to try to find media content in Portuguese. I have a lot of movies that I've purchased in English, but I'm teaching my daughter's Portuguese, and so I try to find all of our movies in Portuguese. And so in here, I can say, you know, all these words. Yeah, I want to have LDS Temple, or I want it to have like this exact phrase, you know, and I could have, you know, like Spokane, Washington, or whatever, and it would have to have this exact phrase. I can also limit it by site if I want to search from a specific site. You know, some sites have like a little search box up in the corner that never works quite as well as Google. Okay, but if I wanted to search like byui.edu, for example, I don't have to rely on BYUI search. I can just use Google and restrict it to a single site. File type, okay, let's say I wanted to find a movie or something like that, then I could search for those. Or if I wanted to find a PDF or something, you know, so there's lots of different things that you can do with the advanced search in Google. And technically speaking, in code, all of that boils down to what we are looking at right now. So if I said, I want to find pages that have Madison written in it, has either county or parish written in it, and doesn't include Idaho, okay? I could write that in JavaScript by saying Madison and county or parish and not Idaho. So this would return everything to me that has Madison, that doesn't have Idaho, and that has either county or parish. Okay, and I could do that same thing. If I was looking for a file type of a PDF, then I could say, and file type is equal to PDF, or, you know, or any one of these. Okay, and there's a lot that you can do with it. I actually had, let me go back there real quick. I made a website at one point that would it basically functioned as a movie guide. And so anytime we bought a movie, we would just search for that movie and it would add it to like our little like movie database. Not that we could watch it there, but it was just a way to organize it. And then I made a way to search for movies and filter movies by their title, by actors, by runtime, by genre, by rating, by the year it was released. So if I was like, you know what, I want to watch like an action movie that was made in the last 10 years, or I want to watch like a chick flick that was made in the 80s, like I could search for any of those, and it was just using a lot of these different conditional statements. Okay. Another example, look on the internet to find a small flatbed trailer to purchase in Southeast Idaho. Craigslist is a great place to look for stuff. Unfortunately, at Craigslist, there isn't a single category for trailers. Instead, there are trailers and bikes, cars and trucks, farm and garden, motorcycles, RVs. It would take far too long to look in all these categories. So we could use a Google search to search this for us. All right, I could say flatbed trailer, doesn't have gooseneck, and is only searching from the site eastidaho.craigslist.org. Okay, and what that would look like in JavaScript is it has to have flatbed, it has to have trailer, it can't have gooseneck, and the site has to be equal to eastidaho.craigslist.org. Okay, a lot of really cool stuff that you can do. On this example. Shonda, I can't tell if that's like a blank mind thinking there, or like just that you're in awe, or that you like don't want to be here. How are you feeling?
Sorry, it was my son touching
Or
me
if it's your
today.
son.
So sorry.
No, you're good. No worries. That's actually really funny. All right, truth tables. We create a truth table by considering two or more conditions. For example, if GPA is greater than 3.5, I could represent this as condition A. All right, and then I could just say if A is true, and then that would be linked to if GPA is greater than 3.5. And if balance is greater than 100, I could represent as B. With two conditions, there are four possible outcomes. All right, let me actually pull up just a little spreadsheet real quick. So let's imagine this. Let's say I have condition A, which is equivalent to GPA is greater than 3.5. And I have condition B, and I'm just naming these conditions, and I would say balance is greater than 100. All right, and then over here, I would just, for every possible condition, all right, so right here I could say, I'm going to put this there and this there as well, all right, so given any two conditions, there would be four possible outcomes. So either both of these are true, all right, or if balance is true and this is true, then I could put that right there, and I can like map this out given every possible outcome. All right. Another way to think about this, imagine that I had, those like briefcases that have like the combination locks, has like those like three little dials. Okay. Well, imagine those dials only had like two numbers. It was like one or two on each dial. Okay. And there were only two dials. Okay. I would have four possible outcomes. Either they're both ones, either there's a one and then a two, or a two and then a one, or they're both twos. Okay. If I had three, each with two numbers on them, then I would have multiple conditions, and we'll look at a couple of examples here. So given this truth table, I'm looking at A and B. All right, so my first two columns have to do with A and B. All right, if they're both false, if one is false and one's true, if the other is true and the other is false, or if both are true. So these are all of the possible outcomes of A and B, given that they are either true or false. Okay. In column 3, I am negating A. Okay, so wherever A was false before, if I negate that, it'll be true here. Wherever A was true here, if I negate that, it'll be false in column 3. Same thing with column 4. It'll be the exact opposite of column B. All right, where B was false, negated B will be true. Where B was true, negated B will be false. All right, and then we start mixing these up a little bit. Okay, for column 5, I'm looking at A and B, all of the possible outcomes of A and B being true. And I see it's false, 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 and then true. There's only one possible condition of this being true, and it's if both of them are true. All right. If I look at A or B, our inclusive or, as long as one of them, at least one of them is true, then my A or B will equate to true. So the only case that it would be false is when both A and B were false. And then if I look at my exclusive or, A or B, that is only true when one of them and only one of them is true. So I get my two rows in the middle that are true. Okay. Any questions on this? we use truth tables to help us visualize the outcome of certain situations. Okay, so we've looked at several cases today, you know, like with the Autopia ride or the girls' classes and different things like that, you know, and using truth tables, I can see every possible outcome. All right, if I say A and B, oh, well, there's only one possible outcome where that would be true, and they both have to be true for that to be met, you know, and so forth. All right, example 8, given any two conditions, A or B, show the result of A or B and not A. Okay, so column 3 is the exact same thing as column 6 up here. All right, inclusive or, all of them are going to be true if at least one in these values was true. Okay, and this will be the, so we have and right here. This is saying where and, well, let's actually go to column 4 first. I don't know why these are out of order, but column 4 says not A. All right, so not A is just the exact opposite of column 1. All right, and then right here for column 5, I'm saying where column 3 and column 4. Okay, so basically I would just look there. So column 3 has trues on the second, third, and fourth rows. Column 4 has trues for the first and second rows. And so if inside of an if statement, if I had A or B and not A, it would only equate to true in this scenario if A was false and B was true. Okay, so when you're looking at these, it's important to look at the column numbers to kind of see what order you're looking at things. Otherwise, it'll be hard to understand, you know, what's in the middle. But again, you can use these to see possible outcomes, every possible outcome. Okay, and you can imagine this would get a little bit more intense with multiple variables. If I had 3 variables on here, I would have several more rows and different possible outcomes. Okay. All right, this is another example from your book. Okay, given any two conditions, A and B, prove that not A or B is equivalent to not A and not B. Okay, so again, look at the column numbers. All right, we'll look at A first. A is either false or true, and B is either false or true, and we have 4 possible outcomes here, same as the other tables that we've looked at. Then I'm going to jump over to column 3, this guy right here. A or B, inclusive or, leaves 3 trues right here, where either or is true. And then 4, I'm negating that. So I'm just reversing what column 3 was. So I'm saying not A or B, we'll leave it as, you know, both of them have to be false for this to be true. Okay, that is equivalent to, if I look at this side of our table, not A, okay, again, the exact opposite of column 1, not B, the exact opposite of column 2, and then I throw those together where not A and not B is true is only that first row. Okay, and you can see that this is true as well as the top one, column 4 and column 7 match. And so you can see that both sides of these are equivalent. Okay. Any questions on this? Okay. So there's these buttons in the book, at least the digital book in iLearn, that are really helpful because it kind of helps step you through it with nice highlighted things. Okay, that can be really helpful as you're working through these. But again, look at the column numbers. That'll really help you as you're working through your truth tables. All right, common mistakes. Forgetting the left-hand assignment of a second comparison. Okay, remember I said if age was 14 or 15 for our girls' classes, that would always be true because your program will see 7 or 15 or any value as true as opposed to false. The only way it would see that as false if it was 0. Okay, anything other than 0, it will see it as true. Okay, so the correct way to write this would be to say if y is equal to 6 or y is equal to 7. Every other one of these ways is false and will not give you what you want it to give you. Okay. Forgetting the and. I know that some of you are taking a Python class right now. This would work beautifully in Python, but it does not work in JavaScript. Okay. In JavaScript, you have to say 10 is less than x and x is less than 20. Okay. Mixing up the logical operators. Okay. So look at this one. if x is greater than 10 or x is less than 20. No matter what x is, as long as it's not like a letter, it's going to be true. No matter what. Okay, so you probably in this case the user probably meant to write if x is, or if 10 is less than x and x is less than 20. Okay, let's look at this one. This one will always be false if x is equal to 8 and x is equal to 9. That's impossible. There's no point in having an if statement here because it's always going to be false. I might as well just write false inside of these parentheses and it'll give me the same thing. All right. Most likely the user meant to write if x is equal to 8 or x is equal to 9. Okay. All right. Unnecessary comparisons. Remember my girls' class example? How I had all those conditions, you know, if age is less than 12 or if age is 13 or 14 or, well, it's 12 or 13 and so forth. Okay. I could do that exact same thing by saying if age is less than 8 or if age is less than 12 or if age is less than 18, whatever values I needed. Because if I reach this second block of code right here, I know that age is not less than 8. And so in here, I don't have to say if age is greater than or equal to 8 and less than 12. I don't have to say that because if I got here, I already know that this was false. Okay, and so all I have to check for is if age is less than 12. Okay, and again, I mean, if I did this first one, this incorrect one, it would run just fine. A couple reasons to discourage it though: it's harder to write, it takes longer to write, it's harder to debug, and you're more likely to have unanticipated errors. Okay, the more logic you put inside of an if statement, the easier it is to mess up something or to have an edge case that didn't get an option, you know. And so the more simple you can make it, the better, even though that theoretically, you know, this would run just fine. So, all right. Any other questions? I guess the last big one here. So I included this in my video. Whoops. I included this in my video from this morning that I posted on the announcement. Still seeing people mixing up our assignment operator, our single equals, and our comparison operator, our double equals. Okay. Let me just show you guys one more example of that. So here's my code. Let's say in here I had a double equal. So if I said if driver is equal to 54, that would check to see if driver has the value of 54 in it. If it's true, then it would go in here and say enjoy the ride. If I have a single equals in here, watch what happens. So I'm going to copy the file path and open it up in my browser. And I'm going to say the driver is 18 inches tall. That's like the size of my son right now. And the passenger's height is 60 inches tall. And check height. Okay, driver's 18, passenger's 60. As soon as I run this code, driver is now 54 because I used a single equals, which assigned 54 to driver. And so this will always be true. Okay, because every single time you'll assign that value and that will be equal to true and it'll always go inside your if statement. So not only will it go into your if statement and you didn't want it to, but it also changes the value of driver or whatever variable you're working with. So be very careful about your single equals and your double equal signs. I feel like I've been talking nonstop. You guys have any questions? Can I help you guys with anything? All right, well, you guys, it's been a pleasure. And if you have any questions this week, just let me know. Again, don't forget about the video spreadsheet or the fact that I am here for you as your teacher, okay? So if you need help, feel free to email Emily. She's awesome, but also feel free to email me. I'm more than happy to help out. Michael, you are very welcome. You're very welcome. I'm glad that it's helpful for you. So, all right, you're welcome, guys. I'll have this uploaded in a couple hours. Zoom takes a while to have it available to me, but I'll post it when I can. So I hope you guys have a great day and a great week, and I'll talk to y'all soon. All right, see you guys.